We're picking up on the N2 Part 2 data sheet, and we're on question 15. We were looking at acceleration versus net force graph. We assumed that the slope of the graph was 3 meters per second squared per Newton. And we found out in the mathematical analysis that the physical significance of the slope, which had units of 1 over kilograms, turned out to be 1 over the mass of the system. So if you literally take the number 1 divided by whatever the mass of your system is, that should give you pretty close to the value you got for the slope of your graph. What is the y-intercept of your graph? This is one that we should have had a graph that was directly proportional, so the y-intercept for our graph should have been 0. And the units that would have gone with that are for meters per second or meters per second squared, because it's acceleration, meters per second. And what does that slope represent? We had already talked about this up. It's the y when the x is 0, so the acceleration when the net force equals 0. So when the net force is 0, that's the acceleration. Next up, we have some calculations using Newton's second law. We've got acceleration as net force divided by the mass. It says we've got a net force of 10 newtons and a mass of 2 kilograms. So 10 newtons divided by 2 kilograms, 10 divided by 2 is 5. And the units are newtons over kilograms. Now, we had said earlier that a newton is the amount of net force required to change a 1 kilogram mass's acceleration by 1 meter per second squared. So we can replace newtons with kilogram times meter per second squared, but kilograms were already on the bottom. So what happens here? Yeah, the kilograms cancel out, leaving us with just meters per second squared, and we have 5 meters per second squared, which those are the right units for acceleration. Take a look at 19. It says if the net force is 20 newtons, and the mass is 2 kilograms, what's the acceleration? So the mass is staying the same, but what have we done to the net force? We've doubled it. Now remember, acceleration and net force are directly proportional, so that might give you an idea of what the answer is going to be, but even before we start calculating. But again, we'll start with Newton's second law, that acceleration is net force divided by the mass of the system. We have now doubled the force from 10 newtons to 20 newtons on our 2 kilogram mass, and 20 divided by 2 is 10. Again, the units are newtons per kilogram. We converted a newton into a kilogram times meter per second squared. The 2 kilograms were on the bottom, so kilograms again cancel out, and we get 10 meters per second squared. And what relationship do acceleration and net force have? They are directly proportional. The y-intercept is 0. We have a positive constant slope. It says if the net force is 10 newtons and the mass is 4 kilograms, I might have deleted this off yours. But you could plug in the net force and the mass here, and we get that value. And I don't know that 22 is on your question, so we'll leave that off for now. That's the end of the data sheet, and next up, you should complete the post-lab check and come back and look for another video to check your answers for that. I hope that helps.